Hello everyone, and welcome to our video on expected value applications and then the definition of a fair game. So a fair game is when the expected value of a random variable is 0. So chances are if it's a real life game, it would not be fair. So it'd be fair for so most of the time it's fair for not the player. Okay, so if I buy a lottery ticket, it's not fair for me. It's the people that run the lottery where they're getting the advantage. Okay, anyway, so let's see it in this problem. So in this problem it says 2 marbles are drawn from a bag that contains 2 green marbles and 1 red marble. If a person draws 2 green marbles in a row with replacement, the person wins $20. First, let's underline with replacement. This is going to help us with the probability. If a person draws anything else, they lose $10. Is the game fair? So they're asking, is this game fair? Well, first we need to find the expected value. And to find the expected value, we will need a probability distribution. Okay, so let's go ahead and set up probability distribution is what's needed here. Okay, so we've got x and then p of x like that. Okay, so x in this case is what happens when we win or when we lose. Okay, so the random number that's assigned for what's going to happen is based on the dollar amount. So even up here, I'm going to label this is if we win, this is if we lose. Okay, so I'm pretending we're playing this game. Okay, so the person wins $20. Okay, so that'd be a 20 right here. Lose would be, well, they lose $10. To show losing in math would be negative 10. And then now we need to figure out these probabilities. Okay, so those ones are set up. So the 20, the 10. Okay, so kind of it's nice to see, I think, those words above. So our probability distribution, this is what's happening in this game. We're either going to win or we're going to lose. And this is what we would win. This is what we would lose. Okay, and then now we need to actually find these probabilities. So that's going to be on this other side of the page here. So 2 marbles are drawn from a bag that contains 2 green marbles and 1 red marble. Okay, so we're either going to draw a green marble or a red marble. Okay, so I'm doing a tree diagram because it is multiple events. We're drawing 2 marbles. Okay, so from there, let's just go ahead and set up the whole branches, and then we'll come back and get these probabilities. They did say with replacement, so that means we draw the marble, look at it, record it, and put it back into the bag. Okay, so with that, there are 2 green marbles and 1 red marble, so that means there's a total of 3 marbles. So that means that should be our denominator. Okay, so the probability of drawing a green marble would be 2 out of 3. The probability of drawing a red would be 1 out of 3. And since the marble goes back into the bag, so it says with replacement, that means the green probability will always be 2 out of 3 for this problem. So let's fill those in, and the red will be 1 out of 3. Okay, and then now we'll find these probabilities. So this is the probability of 2 greens, which would be 2/3 times 2/3. And that would be, let's just leave it as a fraction, 4/9. Okay, because, let's go ahead and underline this in the paragraph. If a person draws 2 green marbles in a row, they win. If a person draws anything else, they lose. Okay, so all of these are the anything else. The probability, so I'm just going to write the probability of lose. Well, this is, let's mark this also, this is the probability of winning, drawing 2 green marbles. So it is also, so it is 4/9. So if 4/9 is the probability to win, that must mean 5/9 is the probability to lose, because that's just doing 1 minus the probability of winning. Okay, so that means we do have those probabilities. So to win, we have 4/9 right here. Probability of losing is 5/9 right there. Okay, so this is how it's done. So 2 marbles are drawn. And then we found the probability of drawing 2. They said you win if you draw 2 green marbles. All right, so now that we have this set up, let's find our expected value. So we use E for expected value. And then we're going to take these and multiply. And then we'll add those ones multiplied together. So the negative 10 times 5/9. Okay, and then at this point, we'd probably use a calculator to get all of this down. Okay, so I've got Desmos open. So that's what I usually use. I just use the scientific one, scientific calculator. Okay, and then, well, I could plug these in. Okay, so it's 20 times 4 divided by 9. And then plus negative 10. 5 divided by, oops, that's not 5. 5 divided by 9. And we get that. 333. So what this represents, so this is expected value. So this is 333. This would be a dollar amount. So this is again, so he's had it in the last video, but what this means is, on average, we win $3.33 each time we play the game. Okay, so that's what it means. So we cannot actually win $3.33 on a single game, but if we play this a million times, it's like each time that we do play, it just averages out to be that we win about $3.33. Okay, so that's what the expected value means. Because the expected value is not 0, so a fair game is when it's 0, this is not a fair game. Okay, so that, we'll just wrap it up. E is not 0, so not fair. Not a fair game. This game would be an advantage of the person playing it because they're winning. They're on average they're winning. So this would not be like a realistic game. Okay, so if it was a realistic game, I mean, jump on it. So because it's letting you know that you're going to win in the long run. Okay, so anyway, so that's how we break down these problems. Okay, so let's see these other two. All right, so in this one, we've got in Roulette. Okay, so that's a casino game. In Roulette, there are 18 red numbers, 18 black numbers, and 2 green numbers. If a person bets $5 on green and it wins, they would win $85, and their original $5 would also be returned to them. What are the expected winnings of betting $5 on green? Okay, so what's going to kind of happen most of the time in these problems is you're thinking of winning versus losing. Okay, because in this game, you're either going to win it or you're going to lose it. That's the two outcomes that could occur. So let's go ahead and set up our probability distribution. And I'm going to mark it again above. So we're either going to win or we're going to lose. All right, and if we win, we win $85. Okay, so that's the X value right there. And then the $5 would get returned. That's how gambling works. It's just letting you know. But either way, so that goes back into our pocket. We did win $85. Okay, so careful with that. Don't do 90 here. Okay, so this 5 is what's important for the loss. If we bet on green and it loses, well then that $5 would be the casino's. So that means we have -5. Okay, so that's where those go. So it doesn't say what exactly happens when you lose, but I mean that's what is going to happen if you lose. Okay, and then we need to know the probability of these. All right, so that's where we could say, well, if we're betting on green and there's 2 green numbers, I would say I have 2 out of however many total numbers there are. So there's 38 total numbers, 18 red, 18 black, and 2 green adds up to be 38. So we have a 2 out of 38 chance to win, which means the chances of losing would be 36 out of 38. Okay, so it's very likely we will lose this game. Okay, and then now that we have this table, though, this is where we would take our verticals and multiply them. So the X value times the probability. This will give us the expected value. So we have 85 times 2 over 38 plus -5 times 36 out of 38. Okay, and now I need my calculator again. Okay, so let's go to the Desmos. Okay, so I've got I'm just going to copy this and change those numbers. I don't know if this is faster. Let's do it. 85, 2 over 38, and then -5 36 out of 38. Like that. Okay, so I'm just copying it the same exact way that I wrote it. Just double check since I copied and pasted, make sure all the numbers were correct. That looks good. And then we get this. Okay, so negative 20. Well, so because it's a dollar amount, we would round to the nearest cent. So it would be negative 26 cents or negative $0.26. Okay, so this is negative 0.26, which means, so in words, so this negative means we're losing money. So on average, we lose. So I'm writing the word lose for negative. Okay, so we lose 26 cents each time we bet on green. Okay, so that's what's getting us. Okay, so the casino would say, hey, yeah, if you win every now and then, we're fine with that, because we know that each player has to play a lot to win, and well, that's 26 cents for them each time that a player loses. Okay, so that, and again, in the long run, so 26 cents, you might say, oh, that's not that bad, but that's say 26 cents per time that someone plays. The number of times that all the people play in the casino is very high. And so the casino is saying, yeah, this is nice. We'll take this money. Okay, so this is a lesson on gambling, really. Okay, so be careful. Don't go to Vegas expecting to win. So you're expected to lose. Okay, so that's how we do it, though. And I did forget to circle that one. Okay, so that was the verticals, and then always add them up as you go. All right, let's see one other problem here. So here we've got a raffle. So this is similar to like a lottery as well. So these are similar types of problems, but here they tell us that in a raffle, 100 tickets are sold. There's a major prize worth $100, a nice prize worth $50, and 3 minor prizes worth $20. If a ticket costs $5, what is the expected payback for a person that buys 1 ticket? Okay, and let's also make a note. I should have said something last problem. Expected is what's important. This is expected value. They just change the word sometimes, so expected payback here. Same deal with this one. Expected is the important one. Winnings, this is still expected value. So expected winnings is expected values. Okay, so sometimes they tweak it just a little bit. All right, well, anyway, what I need in this problem, again, is my table. So that's the main thing. If you get the table, then the rest is going to be much nicer. All right, and then just like before, well, if someone buys 1 ticket, they're either going to win or they're going to lose. So this is a very common expected value style problem. So you're either going to win or you're going to lose. Now, there's different ways to win. Okay, so there are multiple ways, and let's go ahead. I'm going to make a table then, or make some lines in the table. There are 3 ways to win. There's a major prize, a nice prize, and a minor prize. So let's go ahead and set that up. So this part is the winning, just to label it kind of above. And then over here, the rest of it is losing. And there is only one thing that happens when you do lose. Okay, so let's go ahead. I'm going to kind of box this. Okay, so the lose is to the right of this purple. Okay, so there's only one thing that happens when you lose. Okay, so anyway, and maybe let me mark it there, so keep it kind of nice looking. Okay, so, well, let's focus on the losing first. I think that would help in this problem. So if a ticket costs $5 and somebody loses, well, then they're down $5. So -5 would be the loss. And then the probability would be, well, if 100 tickets are sold and you lose, then, all right, well, actually, let's think about these other ones before we get to it. Let's come back to the probability. Sorry. So let's go ahead and get these other winnings involved. All right, so we have a major prize worth $100. So there's the major. A nice prize worth $50. So there's the 50. And then 3 minor prizes worth $20. Okay, so it's one of these 3 outcomes. However, so here's where it's tricky. So I wrote those in. I hope you have ink or enough space. In this problem in the raffle, you're not going to get back the $5 that you bet. It doesn't say, or so it's kind of like a bet. You're not getting the $5 back after you buy the ticket. Okay, so in the gambling, you get your $5 back. So this $85 is the actual amount that you win. Here, if I, quote, win the major prize, yes, I get something that's worth $100, but I did spend $5 already to get it. So that means I have to make an adjustment to all of these. This is actually 95, the amount that I actually win, because I spent 5 on it. 50 would automatically become 45. 20 automatically becomes 15. Okay, so again, very careful of these raffle scenarios or the lottery, because you're not getting your money back with the ticket, even if you win. So again, gambling a little different, because this $85 is what you win. $5 is just goes back in your pocket, as it would have. Okay, so you would say, I won $85. Okay, anyway, so same deal with this. So you have to make the adjustment. You got to figure out what you actually win in these problems. All right, so now that we go through it, well, let's look at, I'm going to change my color to green. So they say there is one major prize, there is one nice prize, and then there's 3 minor prizes. So there's 5, so it just says A. I'm assuming that means 1. So there's 5 prizes, totals, 5 prizes, which means there's 95 ways to lose. 95 or not ways, but let's just say 95 tickets lose, because again, 100 tickets are sold. Okay, so this helps me with the probability. So let's go to the lose again. You have a 95 out of 100 chance to lose. And then for these individual probabilities, just the number of actual prizes that were available divided by 100. So there's one major prize. You have a 1 out of 100 chance to win it. There's one nice prize. So you still have 1 out of 100 chance to win it. And then there's 3 minor prizes. So you have 3 out of 100 chance to win it. Again, notice again that these need to add up to 1. That's a quick way to check it. These do add up to 1. And so did they here. I didn't mention that on this video. I mentioned the last one, but these probabilities should add up to 1. And so when you do, they do. I'm just showing it in green real quick. Okay, so back to this though. Now that we have our table, now we can do our vertical multiplication and then add. So these 2 will multiply. These 2 will multiply. These 2 will multiply. These 2 will multiply. And then we add all of the results. So our expected payback or expected value, E, is equal to 95 times 1 out of 100 plus 45 times 1 out of 100 plus 15 times 3 out of 100, and then plus a negative 5 times 95 out of 100. Okay, and then now we have to add all these up. Okay, so I think I could do this without a calculator. This will be 0.95. This will be 0.45. This one would also be 0.45. This one I need a little help with the calculator. Okay, so and if you wanted to, you could verify. You could double check for me. Okay, so this one, what is it? Negative 5 times 95. Negative 475. Okay, so that's that one. Okay, so minus 475. Okay, and then actually I don't know this without a calculator. I might as well use a calculator one more time. Okay, so we're adding those up. Let me try to make it so we can see everything. Okay, so the 0.95 plus the 0.45 plus another 0.45, and then minus 475. So that's negative 290, since it's going to be a dollar amount. Negative $2.90. Okay, so this means we lose. Chances are, so each ticket gives us our expected payback is $2.90. So what this means, or let's just go ahead and say we lose expected to lose. Let me word that a little better. Sorry. So we are expected to lose $2.90 on each ticket. Okay, so that's how we could break it down in words. Okay, again, we can't actually lose $2.90 per ticket. We can only lose $5. Okay, but this is, again, so the way that it's interpreted is if you say this raffle took place every day for the rest of our lives, and you're able to do it every single day for the rest of your lives, then what it's amounting to is that on average we're losing the $2.90 each time we try this raffle. Okay, so I mean, eventually we're going to win the $95, but over time this $2.90 is just chipping away at our winnings each time. So overall we lose. Okay, so keep that in mind. So lottery, raffles, gambling, usually all bad for us. Okay, so try to stay away. Try to stay away if you can, or just remember that, oh yeah, I'm probably going to lose that. If I'm okay with losing, then go ahead and play. Okay, so but if I'm not okay with losing, definitely don't play these games. All right, so hope that helps. Okay, so expected value is done. If you do have questions, let me know. Otherwise, thanks for watching, and I'll see you again soon.